Hello again! Welcome to section 3. In this section, we'll talk about a paradigm called Protocol-Oriented Programming. This paradigm gives preference for using protocol rather than using inheritance. Let's see how it works. In this first video of this section, we are going to learn the theory of Protocol-Oriented Programming. You've already heard that Protocol-Oriented Programming is a programming paradigm. This sentence is true, but the question is, what's a paradigm in terms of programming language? Let's have a look. A good definition can be that a paradigm is a way of programming accepted by the programming language. Think that there are different paradigms. Some of them they are based on avoiding loops, some of them they are based on immutability, and for example, Object-Oriented Programming, which is based on reusing code. Swift is multi-paradigm, meaning that it accepts many ways of programming. In this video, we will compare Object-Oriented Programming with Protocol-Oriented Programming. One remark before continuing. Remember that the core and most built-in frameworks are based on Object-Oriented Programming. You can use Protocol-Oriented Programming, but you cannot get fully rid of Object-Oriented Programming. Let's do one comparison of both paradigms here. Object-oriented programming is based on inheritance. Classes inherit from other classes, bringing all features of the parent class. But what if we don't need some stored properties, for example? We have no choice than accepting it. And what if we need features from a third class? We cannot do too much, as Swift doesn't have multiple inheritance. So, these are some of the issues we have on object-oriented programming. Protocol-oriented programming is based on features which can be created with protocols. Entities, like structs, they implement all protocols needed. And if we need new features, then we can just add another protocol to the entity. Another highlighted feature from object-oriented programming is reference types. It means that we don't have the object itself, we have the reference to the object. This feature sounds like a good idea, but imagine that this object on the left changes the values of this object on the right, and this other object on the left is not considering this mutation. In this case, we might struggle to control what can be controlled and what cannot be. In protocol-oriented programming, we prefer using value types. It means that we don't share reference to the same object. We just copy it. How do we do it in Swift? Basically, we do it with structs. That's the reason I'll explain it in the next video. So far, just understand that there are no structs which will be referenced by two different objects. One more detail we can mention is about the behavior. In protocol-oriented programming, we can have one behavior when an object implements a protocol A. It might have a different behavior when implementing a protocol B, but it might also have a third behavior when implementing both protocols A and B. So, we can have a behavior according to the combination of implemented protocols.